Okay, we can start, Massimo. You can start.
Okay, thank you, Andrea, and welcome back. Welcome again to our attendees in GM International webinar dedicated to safety relay and their application. Okay, well, before starting with our presentation, let me introduce in short myself and my colleague. As already mentioned, I have a pleasure to having with me today Mr. Andrea Spohr, our global manager account. Andrea has over 20 years of experience in the machine and automation market. He has a great expertise in international relations in the automation sector, and has consolidated his experience in Europe. Now he takes care of customers and markets worldwide. And I'm Massimo Pagani, Product Manager and Technical Support at GM International. I've been employed at GM International for about 8 years, and my main role is to receive and process customer technical requests or assist them in the correct choice of products to be used in their application. Furthermore, I collaborate with our research and development department for the implementation of new devices to be put on the market, and with the sales and marketing office to promote GM products worldwide. So before Andrea starts with his presentation, I would like to introduce my company. GM International was born from the experience of Elcon Instruments, and for over 25 years design, engineers and produce a complete range of SIL certified intrinsic safety devices. Our products are used in automation packages such as DCS, ESD, fire and gas, marine, and so on, in several industrial sectors as oil and gas, petrochemical, pharmaceutical, food and beverage, and railway. The next slide shows the complete range of our products. Here we can see intrinsically safe barriers, safety relay, which we present shortly, isolators, multiplexer, SIL3 power supply, termination boards dedicated to the most popular PLC DCS system, and again a multiplexer, and so on. In addition, our company promotes advanced course on functional safety conducted by an expert trainer such as Tino van de Capelle. You can find all this information about it on our website. Well, the goal of our company is to provide and guarantee innovative and high quality products. All our products are tested one by one and must comply with the strictest work specification. Our products are ethics and SIL3 systematic compatibility certified by third party. And furthermore, over 15% of GM International employees are engaged in research and development of new technologies. Many of our resources are reinvested in the research and the development department. And last but not least, all our products are covered by a 5-year warranty. And again, GM International has always been perceptive to market demands. For this reason, its products are innovative in order to get maximum customer satisfaction. The strong point on which GM International bases its activities is the complete pre- and post-sales assistance in order to lead its customer to find the best solution for their application and to assist them in the correct use of the product. In addition, all our products are entirely designed and produced in our headquarters in Italy and are tested in a highly automated process. The following slide show how GM International is located around the world, with over 200 people who make up our staff distributed on all continents. We have a product stock distributed in our main branches in Dubai, Singapore, Houston, and from this year also in Moscow. The last slide lists some of our main collaborators and customers distributed among system vendor, EPC, O&M, and end user. Well, now I'm leaving Andrea time for his presentation on today's topics. Please, Andrea.
Thank you, Massimo. Thank you to you. And we'll start with this slide that shows a little bit the concept of a cell loop, where you have a lot of things, so you have a lot of apparatus. So you start from the sensors, and you go to till the actuator, to the valve, and where there are a lot of different electronic and mechanical parts. And but of course, a SIS, safety instrumented system of function, SIF, it's of course a translator. If you're using a product that has been certified and they have PFD, probability of failure of demand, declared by the manufacturer, certified, of course, is the total for the SIF is addition of the all parts. Means that all system, all parts needs to be compliant with the functional safety rules. This is the first topic. So you have, of course, we are talking about the sensor, in this case, the barrier, the logic solver, which is connected with the relay itself, and the electronic valve and the mechanical part as well. We want to start with this also, Paul, please, if you want to answer to this, Paul, to take just 1 minute of your time, just to understand what is your expectation, what we are using, what is your experience on this market. It's very, just 1 minute of this webinar for this Paul. We have another other two, but it will be very short. Okay, thank you. Okay, we are going to close it. Please write if you're still there. Okay, I'm going to close it. So most of you have experience with no SIL-rated relays, and so we will try to answer to your question today. Why is it important to use a SIL rated relay? So safety relays for critical applications. So we are talking about really critical application can be used, of course, also in hazardous and non-hazardous, but it's critical. So it's a requirement, of course, must be used in a SIF, and safety integrity function. And this must be conformed to and adhere to ISC 61508 for the most critical industries. So as a producer, we have to be compliant with the ISC 61508. As users, we have to be compliant with the 61511, which are the same standards for the safety industries. When you have to use a safety relays, of course, there are different cases, but first is when your output is not able to supply the current or voltage for the load you are connecting with. Okay, so that is the first point. Also, it's important when you need a multiplication contacts. So when the contacts are, you need more than one, so you want to replicate it. Or maybe when your safety function must be inverted, you want to close and you have an open or close contact, you want to open and you have open contact, so in a safe state. So you want to invert it. Of course, a safety relay are not only used, we are, of course, say, concentrated on oil and gas and petrochemical market, but there are other industries where are using. We have different customers that are using also in the railways, power lift, power distribution, any other, say, chemical critical application where the safety is a must. This is the typical application. So you have your PLC out, which is connected with this blue relay, and the contact is activated by the DCS, of course, on the PLC out. You can use with a solenoid valve is the most important application for ESD, for fire and gas systems. But we have a lot of applications also for beacons or other signaling devices where you have to just to light something and light, maybe beacon, of course. You can use in BMS, burner management system, or where you have to start motors or stop motors, AC and DC motors. That is a very simple use, but of course the function must be really granted by the safety limits. Of course, we are talking about the safety relay. So a standard relay you can find everywhere in the market cannot be used for a SIF. It's forbidden. A SIL certified relay is a relay with a non-warranty ability to perform a given safety function. It means that that is guaranteed by the producer that the relay is able to perform that function. Okay. Grant and also certified. That is the most important things. So the safety function is very simple. Safety function can be reached, but it can be start or stop, can be open or a relief valve or activated fire extinguisher system. But this function must be really safe. You must be sure that by the hardware you're using, you can reach that state with a very high percentage. So most of the time, ESD, IPS, BMS, I think you are aware with that, those terminology. The safety function is a normal energized. So you have energized load, you want to energize. So the safety function is DTS, it's called DTS. So energized to safety. But the other way around in fire and gas application, safety function are normal de-energized. So you want to energize to safety. So there are different, you can see different applications, and that's why there are different relays. So there are two, as we said, there are two types, main group, ETS or DTS, energized to safety, ETS, or de-energized to safety, DTS. And there are different conditions. I don't want to tell you all conditions, but of course, all mixed conditions from normal energized coil, normal de-energized coil, and load and so on. That is the typical drawing where you can see all application. You see here in series we have for normal energized and parallel connection for normal de-energized. Let's show some example on that. So this is the application. We have, for example, the coil, which is normal energized, and the load is a normal energized as well. So the safety condition means that I'm de-energized my coil, and also the relay will open, so the load in this case will be off in the safe state. Also, if you are always talking about the normal coil normal energized, and the load in this case is normal de-energized. So the safe state will be reached when the relay will be deactivated. Or say my coil will close the relay, which is connected with the load. In this case, the load is on. This is one application. Of course, you can have the same when you have the coil normal de-energized and the load is on. In this case, the safe state will be reached when my coil will be energized and the relay will be deactivated the load. The last case is this one, when I have my normal case of activation. So when the coil will be energized, my relay will close the circuit and the load will be on. Those are the typical cases for applications. But let's have some further examples of that. So we are talking about the load normal energized and coil non-energized. I see that if I have, of course, the same, not the normal relay, but the safety relay, one relay in the circuit is sufficient to reach SIL2 level. If I wanted to reach the SIL3, in this case for non-energized, I have to connect another relay, which is connected in series, as you can see in the circuit. So I know that in case of safety, I have to open my circuit. In this case, I have two possibilities to open the circuit. That's why I can reach the SIL3 level. So it means that having one hardware more redundant in this case, I can increase the SIL level by 1. So going from SIL2 to SIL3. For normal de-energized, the situation is a little bit different. In this case, I can have just reached up with the one relay SIL1. If I want to reach a SIL2, I need another relay, but in this case, not in series connecting, but in parallel. And if I want to reach a the SIL3, I have to connect another relay in parallel. That's why, say, basically all relays have been designed. But we have other technology I want to show you later. But this is just a small example, simple example, just to understand the functioning for the relays. You know, safety is one thing, availability is another thing. Functional safety, IEC 61111, don't care about availability, just care about safety. And but we do care about availability because we think that is also very, very important. We try to say to maintain the safety by increasing also the availability. And we explain how. So for normal energized, if you remember in the previous slides, we have shown that the second relay in parallel for normal energized will grant a SIL3 level for the application. That's right. But I see that this is lead to very low availability. So it means that one single relay fault, so the contact opens by accident, and I lose my availability, and the non-energized function will be lost. It means that I'm not in the safety situation. I don't want to stop my plant. My plant is running, but by accident, why I got one relay fault and my circuit will go. So high safety, but low availability in this case. Okay. So we have another example for normal de-energized. So for normal de-energized, I have this situation. So one single relay fault welded contacts will lead to a low availability. So in this case, the load will be activated without a real demand. I'm not in the safety. I do not want to turn on my load, but that will happen because one relay got fault. So high safety, because this is SIL3 configuration for normal energized, but low availability. That's in this case. We have another example that maybe help you for non-energized load. I can see the different, you see on the left side of this slide, you see different architecture. So I have 1 out of 1 architecture, okay. 1 out of 2 relays in series. 2 out of 2 relays in parallel, which is not correct at all for this kind of system. 2 out of 3, the voting system. Two relays have to say the same things and the function will be performed. So let me explain by the table on the right side. So the architecture 101, I can say calculating my probability of safe failure per year, probability of dangerous failure per year, which are different. So safe failure means availability, dangerous failure means safety. Okay. So architecture 101, first line, you see that mean time to failure, MTTF, for safe failure is 25 years, while dangerous failure is 50 years. Okay, so those are good, of course. Let's say that are good. But if I realize the architect 102, two relays in series, I can decrease. If you remember from the previous slide, that decrease the availability because one relay can say open by accident. So I reduce my safe failure time. So 12 years, 12.5 years is lower, but increase a lot my MTTF, so my safety by 50 times. 2,500 just in theoretically, of course, because electronic not stand for that long time, of course. For architecture 202, which is completely wrong for these applications, I increase a lot of my safety, but I reduce my availability, 600 years, and I reduce my safety. The voting, in this case, voting system also increase availability, but increase also a lot of safety. In this case, I see that I have to use more relays if you want to compensate a lot, let's say, the availability and safety, because 1 out of 2 is not good for availability, it's good for safety, but not good availability. So the owner for the plant will be not happy if the plant stops because the hardware failed. Okay, hope I will give you some details. So we want to launch another poll. So just understand if the things we said are correct, or say aligned with your idea of safety. Look if availability was important for you or not. I remind that you can make questions anytime to us. Okay. Use just a Q&R in case you need, let's say, ask something. For the poll, just vote there. Let's finish. Okay, I'm going to close it. So I'm going to close it, this one. So I see that availability is the most important features that you are looking for, probably. Okay, let's go further and what we did. So we have talked about in general about safety for relays, but we at the GMI we let's say changed and we try to let's say experiment a new technology, new architecture, as you see in this case. So we realize relays that have 4 relays inside. Okay. 4 relays that if you see on the slide that they are connected in parallel, and 2 relays connect in parallel, then there is the load, and the other 2 relays are connected in parallel. So 4 relays are controlling the load. And we have seen and we have calculated there are, say, of course, our Archimeda calculation is really give us a really good result on that. If you look here, we see that one relay is not sufficient for a dangerous failure. So if one relay was there, that is not sufficient for dangerous because I'm able to open the load because the two relays below are opening the circuit completely. So that is the most important thing. So one relay is failing, but I'm not having any influence on my safety demand. Okay. So even in presence of a single relay fault or value contact, the relay is still able to satisfy the safety function. In this case, open the load on demand. Okay. This is for non-energized. But for normally energized, is also very, very interesting because one relay is that is failing here is not closing when I'm going to ask close the load, not the influence, because the other relays on the other line are able to, let's say, close the circuits. So I see that this kind of architecture is improving the safety because one single relay fault in a non-energized, de-energized application is not sufficient to cause a failure for the function. Okay. But also, this architecture is very, very important for availability because if I talk about availability, I'm working. I have a normal energized application which is working correctly. Okay, I'm not going to open my circuit for normal energized because everything is working correctly. But I'm having one fault on one relay. One is open by accident, but the function is not, let's say, influenced. So my function is still okay. I'm not losing my availability. Okay. So 4 relays connecting this way are sufficient for having safe and available function for normal energized. But the same is for normal de-energized. So if one relay is stuck over there, that is not closing the contact. So I'm not asking for closing contact for normal de-energized. And the function is still okay. Everything is working perfectly. I just know that I can detect one relay fail, but inside one inner relay, not the total relay function. So we have checked that this kind of architecture is very good for safety and availability for non-energized, for normal de-energized application. Okay. That is a step ahead in the relays. You know, in now in application, people are asking more and more for relay with built-in diagnostic systems. What is that? We are talking about relays that are using systems that are very old and can maybe do not support this diagnostic. We are talking about systems with digital output that are current voltage limited. We are talking about maybe the diagnostic inside with some limits and maybe extreme load or earth leakage cannot be detected. We are talking about smart relays or relay with their built-in diagnostic that make this diagnostic available to the system, that are able to detect a fault in the line load and send this data to the system. So in this case, smart relays are able to extend the digital output diagnostic capabilities, which is basically limited to the DCS, to the PLC. So the smart relays extend this diagnostic. The function that is able to alert for any single fault, both for non-energized or non-de-energized application, both cases. So we are going to close this part for the presentation. Is just a part, theoric part, which is based on our experience. There is another part which is coming in a few seconds, and with the details, with the questions. Okay. So, in the meantime, if you want to make any question, please don't hesitate to write on Q&R button on your bottom part. Okay. So I'm launching now this new part.
New presentation. We can open the second part of our meeting. I remind our participants that they can ask their question through the Zoom question and answer function. And in this second part of the meeting, we show which are the typical requests that most frequently are asked to us on the relay topic. Well, we can start.
Yeah, basically, we got this question because this is not the first time we are having this webinar. Of course, we repeated during the year, and but also during your registration time, you made some questions, and I think you will find some details here. Some of yours have been included here. So, question was first was safety relay installation hazardous area. Is it possible? Is it possible? So Massimo will explain you.
Yes, Andrea, it's possible to install a device, a relay, such as safety relay in the hazardous area. Of course, placing it in a special enclosure certified for the installation area. Or, as shown in the slide, in more cases, there are safety relays certified for installation in a hazardous area, especially suitable and certified for installation in Zone 2. This special feature, this characteristic is very important because allow us to install the relay as close as possible to the load with great advantage in safe cable natural, this means safe cost.
Okay, Massimo. The other is a past testing compatibility. I think you are aware about that, but there is another example on that, Massimo.
Okay, thank you, Andrea. Almost all PLC DCS system have the possibility through a series of pulses to test the status of the line that connect them to the relay coil. Compatibility with these pulse trains is very important in a safety relay. First of all, to allow the correct test of the line, and moreover to avoid that these pulses causes the chattering effect in the relay, or to avoid spurious activation or deactivation of the load, as well as damage of the relay itself. This functionality is fundamental, especially in fire and gas application, where it's important to know the health status of the line, as at the time of the request for intervention, we must be sure that everything will work correctly.
Yeah, I want to add these things because sometimes we are talking with the customer every day on their special applications, say that they cannot deactivate the past testing. So also past testing is used when you are not interfacing with the relay, when you go directly to the load. But for the reasons we have explained before, that is not possible. You need maybe safety relays for different reasons. And if you don't have this compatibility, if you're using a relay that is not compatible with past testing, you can have some problem. And in a lot of cases, you cannot deactivate it on your DCS. That is the most important point. So the compatibility is really important.
These features is very important because in conjunction with the relay smart relay allow us, pulse test allow us to have the diagnostic coverage from PLC DCS up to the field load.
Massimo. So I think there is one question we can live. One attendee is asking, do you have approved relay solution for Yokogawa ProSafe RS? We can say yes, because we have say approval test report from Yokogawa. And so we can, if you just send us an email, we can send this test report to you. We have, Yokogawa is a good customer of us. We can say that we use our safety relays in the different applications worldwide.
Yes, we have conducted some tests from Yokogawa process RS system, and especially with our smart relay and also the safety relay.
Okay. I think where we are. Here. Is there any solution offering multiple contact output?
Yes, Andrea, there are solutions that provide for multiple output contacts controlled by a single input. These multiple outputs allow us to have multiple loads connected and driving simultaneously. For example, we can take the GM International Safety Relay called the D5290S 078. These allow us to drive at least 2 SIL loads with only one relay. In fact, this type of relay allows us to have application in which we can simultaneously drive to normally energized SIL3 load, or 4 SIL2 loads, always normally energized, or again, even 2 normally de-energized SIL3 loads. Of course, the possibility of having different loads driven by a single relay allows us a considerable saving in terms of space, as in only 22 millimeters, we have the ability to control different applications.
Okay. Let's go to the next.
There we have a question from our attendee.
See?
How to identify permanent contact close. I think our attendee is referred to a T-proof test of the safety relay. All safety relay have the possibility to perform health test for the contact, and this test is described in the safety manual of the relay.
Okay, I think one unipolar or 2 bipolar wires load. That is another
important feature for the safety relay, and the safety relay can be connected in unipolar or bipolar configuration. A bipolar connection allows us to completely isolate the load, and this is recommended, especially in application where the load must be powered with high voltage. From an electrical point of view, this type of connection gives us greater safety thanks to the complete isolation of the load. A unipolar connection instead isolated the load only on one of the power supply lines and allow us to bring a negative to earth in case of need. Furthermore, this type of connection allows us a great benefits from the point of view of cable savings.
okay.
Andrea, we have another question.
Yes.
Does GM International have functional safety management certificate or procedures to demonstrate functional safety management system?
I can answer because we do have, of course, a functional safety management certificate, which is mandatory for companies like us that produce. I would say that is also mandatory for any company that are involved in the safety application. So if they, for the people, probably this attendee already know, but maybe we can explain for the other. This FSM certificate is mandatory for all companies that are involved in any application for in the safety. So if you want to be, you want to work and let's say allow to be a player in this market, this will be required by the customer when you are supplying the service.
Thank you, Andrea.
Okay, we can go further. I think, let me see if we have, yeah, how choosing a relay. A lot of times people asking us how to choose a relay because there are different technology. We have a very wide range and people don't know how to use it, but we can give some idea. No?
Okay, thank you, Andrea. But the choice of the correct safety relay must be made taking into consideration various factors, such as compatibility with PLC pulse test system, the type of coil power supply, the safety function that is must perform. In this regard, it's important to say that the choice of the relay is fundamental relative to the type of load and the safety function it must perform. In fact, it would be very harmful to choose a relay that performs a safety function different from the one required by the application we have to create. Suppose, for example, to choose a relay suitable for normally energized load to drive an fire and gas system. This would greatly increase the risk for our system, as using a wrong relay in its safety function increases the chances of failure in case of a relay intervention request. Therefore, it's important to choose the relay correctly based on the safety function it will have to perform. Furthermore, let us not forget that the choice must also be made, bearing in mind the need for a diagnostic capability on the part of our relay, the need for single contact or multiple contact, and finally the contact rating of the relay. Even in the later case, the choice is important, as choosing an incorrect contact rating can have serious consequences for the state of health of the relay and therefore of the entire application. And
question.
Yes.
Is safety relay applicable for fire and gas? I assume that fire and gas won't have a SIL target as it is a mitigating system. Can you answer to this question, Massimo? I think it's a yes.
Yes, thank you. But I think that this answer I prefer to have some time to think about the answer and send an email from our attendee to give a correct answer.
Okay.
And the ABF value for this relay is another question. MTBF value for this relay can be found on safety manual for each of our safety relay. Andrea,
We are talking about years, 50, not about 100, 150 years. That are the standard. We have it. But MTBF alone cannot say, cannot certify, of course, the relay. Okay, we can go through the next question. Can the fault for monitoring the relay be mirrored directly to the PLC DO? This is very important features. I want to show this to you, Massimo.
Yes, Andrea, there are relays that when they detect a fault in the field, can, through a variation of the dynamic impedance of its input, send a fault signal to the most modern supervised PLC DCS system. Natural, of course, if the PLC DCS system are compatible with this function. This function allows us to reflect information related to the field fault directly to the supervised digital output card of a PLC, both in the off state through the pulse test system and in the on state by reading the static return of current. The DO card of a PLC can detect the information relating to the field fault. This system, through an upward impedance variation of the relay input circuit, allows the supervised digital output card to see the fault in the field. This system allows considerable saving in engineering cost, as it allows us not to use a dedicated digital input card for this purpose.
This is also fault mirroring is available on for most important DCS PLC. Not okay. So the experience with different, but with some is not possible. So if you need more detail about that, about the system you are using, we can let you know, of course. Okay, so next question is, can the fault for monitoring relay be interfaced with a field bus? No.
Yes, thank you, Andrea. There are particular safety relay models called smart relay, which can provide the complete diagnostic information through Modbus multi-drop RS485 protocol. Of course, if a Modbus master is available on the system side. Up to 127 modules can be arranged in a multi-drop network and monitored, configured by a single master unit, as shown in the following picture. Through an address and when requested, makes available its value for the reading writing. What are the advantages of using Modbus communication? With a single Modbus RS485 interface, it's possible to connect and communicate with all the relay present on the same bus. Multi-drop connection is possible, and communication can cover a distance of up to 1,200 meters. And another advantage is the possibility of not using a dedicated digital input system to monitor alarms. This, of course, allows us to have significant saving in terms of cost and to have real-time information on the type of alarms and on the health of the load and the line status. It's also possible through Modbus a complete remote programming of the relay.
Okay.
Well, thank you, Andrea. Another question, typical question regarding SIL. A SIL3 relay can be used in a SIL2 application.
And it's my turn. So this is a question, because people are facing with the SIL2 or SIL3 application, and we are offering mostly SIL3, but also in the SIL, some of them are SIL2, but basically if I have a SIL3, can I use for SIL2 application? And you know, the SIL level can be 1, 2, 3, and 4, so 4 is the most dependable. But definitely SIL3 relay can be used as SIL2 application, but not the other way around. So you cannot, reach or arrive at the SIL3 SIF if you use SIL2 relay. So the higher SIL is the most important solution, and also in the SIL2 application. And what is also the importance to use a higher level of SIL for a relay or for a system when you just need a SIL2 in this case? The thing is that you reduce a lot the T-proof test, very important. It means that, for instance, if you're using SIL3, that product is SIL3 that is stands for 1 year in the SIL3 application, that easily could become a SIL2 for 10 years. So increase a lot this T-proof time. So it means that you have to test less, you have to stop less your plant because you don't need to perform the test. That graph means, let's say, explain how the PFD degrades by the time. So when you start the SIL3, after a few years, probably you are in the SIL1 if you don't test your hardware.
Okay, thank you, Andrea. Another important aspect regarding safety relay is related to the design of this relay. And please, can you explain about
the thing is that safety relay is not a standard relay. The cost is different on different application, different situation. So basically, well, you can achieve the SIL by using different architecture. So we have seen that 1 out of 2, 2 out of 2 are a good combination. In the same way, this architecture also used for components inside. So the single components inside are redundant in the relay. And of course, we have to consider also the beta factor. So if you use this component to create a redundant application, those components can fail by the beta factor, say, factor, meaning can fail at the same time, because if they produce by the same manufacturer from the same batch, probably could fail at the same time. That reduces a lot the reliability for those hardware. Other things, of course, are the level of components. So we are talking about better components that bring to better results on your application. So if you are having, if you are talking about this safe failure fraction higher, let's say, allow to have a better level of SIL with higher fault tolerance. Of course, talking about gold plating relays, SIL relay, force contact, single or multiple contact, internal contact. The last things are the F-made analysis. F-made analysis is the biggest part. So, of course, for each component, we have to check and we have to, say, buy components that are supplied by manufactured components and in the market with beta, say, F-made analysis in detail. So, for each component, we have to know which are the lambda, say, so the failure rate for safe failure and for dangerous failure for each component. So, and for each component, we have to calculate and check what is the behavior on the product itself. So the meta-analysis is very complex, but is the only one that can state that the product is reliable.
Andrea, we have a request from our attendee.
Yeah.
Can you share model numbers of GM International Safety Relay?
Of course, we can share in a separate email. If you send us an email, of course they are available on the website. But I think you meant about probably the relay with the matrix architecture, and probably the 5294. But if you explain better in a separate email, we will answer soon to you. Thank you.
Thank you, Andrea. Another question is related to the contact. Why gold-plated contacts are important in a safety relay?
Okay, so gold-plated, basically, let's talk about that. So basically, relay are used when you need more power on your load, that is your output is not able to give, and but maybe switching current maybe is lower than 100 milliamps in this case can happen. So there are different cases, and gold plates are very important because the small current can cause oxidation and spurious nuisance. We've seen that the contact can weld. So it's very important to use because gold on the contact itself can eliminate this oxidation that causes the nuisance plate. So gold plate grants this reliability up to 1 milliamps, and of course those are used on GMI relays.
Okay, thank you, Andrea. And another question about coil voltage and relay load currents.
Yes, we have different solutions. So the coils are different. We have a 24 volt, which is the most common. We do have also a solution to 48 for use in some area and some application, 110 VDC, 115, and 230 VAC. And we have for normal open, as we say, for normal close, multiple contacts for normal open, multiple contacts for normal close. Relay can be 3 amps, 5 amps, 10 amps, so different solutions for different applications.
Okay, thank you, Andrea. And another question is related to the MAP relay and the SIL3 relay with SIL2 diagnostic. How is it possible?
Is it possible because you see the diagnostic is the orange circuit, and say the safety function is the red one. Those are completely independent. They are not interfering each other. So the safety function, the red one, is certified for SIL3. The diagnostic is a more software, let's say, functionality, and that is very hard to certify for SIL3. But even if it's only SIL2, it's not completely interfering. It's not interfering at all with the safety function. That's why you can use the diagnostic SIL2 while the safety function remains at the SIL3.
Yes, we can say that typically in the smart relay, 2 different safety functions coexist inside. The first and also the main function consists in input to output or coil to contact activation, deactivation. This is the typical function of a safety relay, which upon request is able to drive a load applied to it in a safe state. And the second one is the diagnostic function. It provides full measurements voltage car resist air leakage of the load also through Modbus protocol, and it can activate, deactivate through fault dry contacts.
Okay, good.
Okay, the last question is relating to the difference between process and machine safety relay.
Yes, there are always, we are having this question, people asking, what is, can I use? No, you can't. We are talking about process applications that are completely from machines. So the process we have seen are required for, require SIL certification, application of valves, horn, light, sounder beacons. There is no manual control at all. So there are no manual control. You can't control by manual operation that relay. So it's a system that is closing contact, the relay has to answer immediately. And when it's released from the system, the relay has to release it itself. Okay. So it's a completely different behavior, because for machine, there is a specific certification with the PL, performance level, which is also safety, safety from Q, from any other accreditation body. But applications are for safety gates, light barriers, grids, speed, standstill. So there is a manual control. Typical application is a mushroom on the plant you find everywhere, and that is controlled by safety relays, but dedicated for machines. So we are in another world, separated, parallel world, but another world. Okay, this was the last question. I don't see further question from you. I remind you that there are other webinars on our say calendar on our website. You can find the upcoming. We are also thinking to enlarge this program by new topics. We will be ready during next year. We got know, of course. On our webinars, sorry, on our website, you can find also all registrations for this webinar and for the others. So you can read at any time and then look at any time. So if you want to forward to your colleague, you can. And we have the last poll. So just to know what is your say vote on that, if you like or not this kind of webinar. Thank you very much for answering. We'll remain. I remind you that we answered to your question. We got your email for the ones that asked it. If you have a further question, we'll remind you later our emails. You can send us phone us anytime we are available. We have a lot of different experience on our portfolio. Thank you. Stop now for voting, and remind you again our name and face also. And we'll look forward to see you again in the next webinars. Thank you, Massimo.
Thank you, Andrea. Thank you all our attendees, and see you in the next webinar.
Stay safe. Bye.
Bye. Bye-bye.